Let us ask group 1 to start reading 2.2, more graphs and displays.
Okay, I think I go first. Graphing quantitative data sets. In section 2.1, you learn several traditional ways to display quantitative data graphically. In this section, you will learn a newer way to display quantitative data called a stem and leaf plot. Stem and leaf plots are examples of exploratory data analysis, EDA, which was developed by, oops, sorry, I lost it. Okay, by John Tukey in 1970. In a stem and leaf plot, each number is spreaded into a stem. For instance, the enter is leftmost digit, and a leaf, for instance, the rightmost digit. You should have as many leaves as there are entries in the original data set, and the leaves should be single digit. A stem and leaf plot is similar to a histogram, but has the advantage that the graph still contains the original data. Another advantage of a stem and leaf plot is that it provides an easy way to sort data.
Okay, thank you very much. Group 2, please read example 1 for the class.
Example 1. Constructing a stem and leaf plot. The data set lists the numbers of text messages sent last week by the cell phone users on one floor of a community dormitory. Display the data in a stem and leaf plot. Describe any patterns.
Thank you very much. Okay, here you have a sample, you have some data, some information, and note that these are all numerical values. These are all numbers. So here we have some numbers. These are not categorical data. Guys, this is just numerical or quantitative data. Quantitative data. Very well. So to use stem and leaf plot, what do? We start by finding smallest value in the collection. Okay, we have to look for the smallest value in your collection. Okay, look at the first row, look at the second row, look at the third row. Okay, on the fourth row, you see 78. Very well. 78 is the smallest value in your collection. Very well. Okay, so you write down 7 on the left-hand side and 8 on the right-hand side. And you use a vertical line to separate these two digits. Very well. Okay. Let us look for the next number. The next number here is, okay, after 78, what do we have? We have 10, okay, we have 105. Nothing in between. So next number, next is 105. What do? You're going to take 10. You're going to write down 10 on the left-hand side of the vertical line and 5 on the right-hand side of your vertical line. Next number, let us look for next number using the order that we have here. Next number, okay, 109. Do I have anything smaller than 109? Yes, I have 108. Next number is 108. Perfect. So again, you have 10. 10 is already here, and you add 8 next to 5. So you read it as 105 and also 108. 105, 108. Okay, next number, 109. Okay, I have two 109 on this row. 109, 109. Okay, 109, 109. Let me look for the next number. Next number, do I have any other number in the same range? Okay. Oh, yes, I have another 109. Perfect. So 10 on the left-hand side, 9 on the right-hand side. And you continue finding the rest of the numbers and form your stem plot. Please take your time if you want to write this down.
Sorry, can I ask you a question, please?
Go ahead.
Is it okay if, so the lowest number is 78, then after 78 we have 105. So is it okay if we don't write 8, 9?
That's fine as well. That's fine. You can just ignore these.
Okay, okay. Thanks.
Makes sense for everyone? Any question here? You're done writing this down. So thank you for using chat. How do you know the next number would be 105? You have to look for it. There is no other way. So you have to look at this data. Okay, what numbers do I have? The first number, the smallest number is 78. After 78, do I have any 79? Do I have any 80? Do I have any 81? Do I have any 82? Do I have any 83? You look for all the numbers. So after 78, after looking at all of these rows, you see the smallest number is 105. After 105, the smallest number is 108. After 108, the smallest number is 109 and another 109, another 109, and you have to keep going by looking at the collection. Any other question here? Move on to next page. So, question. Yes.
Yeah. Are you gonna go over like the 112 and then 116? Why it's separated?
112.
Like, yeah, like I see 112, 112, 112, 113, 114, and then.
So after 105, you have 108. Then you have 109. Then you look for the rest of the numbers.
Yeah,
So,
yeah, I see. But I'm saying on after 109, it's 112, correct? The next line down. I was just wondering why 112, and then if you look down, 116 is separated. Why can't it go in the same line? Like, why can't 116 go where 112 is as well?
So after 11, you have 12. After 12, you have 13. After 13, you have 14. After 14.
No. Yeah, I understand that, but so you have right here, you have 112 3 times, right?
Yes.
Then you have 113, then you have 114, and then the next line skips down.
Oh, you can copy these down here. It's just, you know, that's absolutely fine.
You can keep them on the same line though, right?
Yeah, you can move these and write them here. 6, 7, 8.
Yeah, that's what I was wondering. Okay.
Yeah, of course.
Yeah, okay. Thank you.
9, 9, 9. Yes, of course.
So
thanks for asking. Yeah, the same here for 12. You can just copy this 6, 6, 6, 9, 9, 9 here. 13.
is that, sorry.
Go ahead.
Is that the reason why, like, can it be the same for 15? Because then it's skipping on for 15.
Yeah, so you can just ignore this 15. For 14, you can move these 5, 5, 5.
Okay, thank you.
7, 8. For these 13, you can just ignore this line and write down 9, 9 here. Yes, absolutely. Absolutely. Any other question? Make sense for everyone? move on to next page?
Yeah, I think we're fine.
Okay, perfect. Okay, after stem and leaf plot, you can use something that you call dot plot. So what are we going to do? We're going to use a dot, one dot, to represent each number in the collection. So you can use dot plot using some dots representing each number in the collection. For example, take a look at this example. You have some numbers, they're just repeating the exact same collection from previous example. Okay, so smallest value was 78. So you use one dot on top of 78. Next number was 105, and we had only one 105. So you put one dot on top of 105. Then next you have, after 105, what did we have? We have, okay, 108, just one 108. Okay, one dot on top of 108. 108. Then remember that you had 1, 2, 3, 109. So you use 3 dots to represent 109. And you continue the process using some dots representing each number in your collection. You can just connect these dots and see the shape of your graph. This method is called using dot plot to represent the data. So far we talked about stem leaf plot. This is dot plot. If you have any question, please unmute yourself, use chat. Very well. Let us move on to next page. Very well. I expect you to ask, so far you talked about numerical data, numerical values. Now, what if we have categorical data? What if we have qualitative values? In this case, you can use something that you call a pie chart. Pie chart is a circular shape dividing each category. Very well. In this example, we have 1, 2, 3, 4 categories: associate's degree, bachelor's degree, master's degree, and doctoral degree. The frequency or the count for each category is listed next to that category. Associate's degree, 942, bachelor's, 1716, master's, 731, and doctoral, 164. Your goal is to visualize this collection. So you have 942 counts of the first degree, then 1,716 counts of the second category, 731 counts of the third category, 164 counts of the last category. How do we visualize this? The best way to visualize categorical data is using frequency table. So the best way is to use frequency table and form relative frequency. Okay, remember that to form your relative frequency, you have to find the total frequency. The total frequency is the sum of all frequencies. So to form relative frequency, we need to add all of these counts, all of these frequencies first. So let us take a look at this. The first frequency, 942, second frequency, 1716, third frequency, 731, and last frequency is 164. So 942 plus 1716 plus 731 plus 164 is, how many data do you have? Please take your time, add them all together, give me the number.
Is it 2895?
2895, thank you. So what's the meaning of that? It means that you have 2,895 data in the collection. The total number of data in the collection. So what are we going to do? We're going to form relative frequency. Remember, relative frequency for each class is the division between the frequency of that class and the total frequency, 2895. If you do the division, you get a decimal number, 0.265. So it means that the first category takes on 26.5% of the total circle. 26.5% is related to associate's degree. Do we have any different denominator? If you add them all together, everyone has 2895. I want everyone to participate in adding. No, very good. I have two students with different denominators. What do you have? $35.53. Thank you.
Yeah, sorry, I checked my calculator. I was missing the one on.
That's absolutely fine. Thank you for your participation. $35.53. Perfect. Thank you, everyone. So if you do the division, you get 26.5% for the first category. For the second category, you can find the relative frequency by dividing 1716 by total frequency. It should give you 0.483 or 48.3%. Almost 50% is for bachelor's degree. So as you can see, almost half of the circle is for bachelor's degree. Master's degree, here you get 731 divided by 35.53, which is equal to almost 21%, 0.26. So 20.6% is for master's degree. And finally, the smallest proportion is for doctoral's degree, 164 divided by 35.53, which gives you 0.0 46, or almost 5%, which is the smallest section here. That's how you form your pie chart. So remember, we use pie chart for categorical data. Please take your time if you want to finish writing this down. If you have any question, please unmute yourself, use chat. Move on to next example.
Quick question for you.
Go ahead.
What does it mean by the central angle?
Central angle is, so if you divide this circle using some sections, some sectors, these angles are called central angles. So for bachelors, you almost have 180 degrees. You can multiply each relative frequency by 360 degrees to find the degrees for each category. As long as you form your relative frequency, you are getting the exact same count for each category, which gives you the exact same thing by using the angle. Any other question? Perfect. Very well. So far we talked about bar chart. Now, if we use bar chart and graph bar chart from the largest bar to smallest bar, you're forming Pareto chart. So this is one example of this type of chart. Some bars, which is arranged, which is ordered from largest to smallest chart. Guys, remember that it's different from a histogram. For a histogram, you have adjacent bars. So let me write this here for you. Note, for histogram, all bars must be adjacent. There is no gap between bars. No gap. If you have bar chart, you're allowed to have gaps in between your bars. As a statistician, you need to learn how to use a software to graph the data for you. Your job is to analyze the graph. You shouldn't be worried about the graph or graphing a large data set. Any question here? Very well. Okay, scatter plot. If you have some points per data set in your collection, you can use a graph that you call scatter plot. So you have some points, some X value, some Y value, and you graph them. So in this case, you have some points in XY plane, like the table on the left-hand side. So on the left-hand side, it says, very well, length of employment, 5 years, salary, $32,000. Length of employment, 4 years, salary, $32,000 and $500. And you have more length of employment and related salary to that year. How do you graph this? You have some points in XY plane. The first point for this table is $5 and $32,000. The second one is 4 years and almost $32,000, $33,000. Next one is 8 years and $40,000, and so on. Very well. Here you can form a horizontal axis, a vertical axis. On the horizontal axis, you can just list these years. So smallest is 2, so 2 years, and the largest is 10 years. Okay. 2, 3, 4, 5, 6, 7, 8, and 9 years. And on the vertical axis, you can just list the salaries. Suppose the maximum stops at $50,000. And the smallest, let's see, okay, we have 25. Okay, $20,000. 30, 40, and so on. Very well, the first one is 5 and 32, 5 and 32, this point. The second one is 4 and 33, almost 33, here. The other one is 8 years and 40K, 8 years is going to be here, and 40. And you can continue forming your scatter plot. 4 and almost $30,000. 4, okay, it's going to be here. 2 and 25, roughly here. 10 and 43, roughly here. Again, by using a software, you can easily visualize these graphs. This is called Scatterplot. You must have points or their pairs to be able to graph scatter plots. In linear regression, we're going to use Scatterplot. Okay. Now let us talk about time series chart. Very well. Time series chart are related to data that includes time, day, month, year, and you're interested in visualizing the data using time. Very well, here we have a table. Our years are listed 2002, 2003, 2004, 2005, and 2012. The number of subscribers and average bill. On the horizontal axis, you have your time, which in this case is in year. And on vertical axis, you have the subscribers. You can use a different color to form the last column related to each year. Then you can see the trend related, the number of subscribers and average bill. Okay, this is the last chart that I wanted you to see. These are famous and popular charts in statistics. If you have any question, please unmute yourself, use chat. If you don't have any question, we're going to start 2.3, how to analyze the data, finding the mean, standard deviation, variance.
By any chance, can you go back to example 6?
Example 6, previous
Yes.
example? Sure. So for this one, here, scatter plot is given to you. On the horizontal axis, you have the length, and on the vertical axis, you have the width.
Okay.
This is the IRIS data set. This is one of famous data set that they use in statistics. Now, here you have a table, and your goal is to visualize the data using scatter plot. On the horizontal axis, you can use length of employment. On the vertical axis, you have the salary. Any other question?
I have a question.
Go
So
ahead.
to form the X and Y axis, so here the chart shows which one is the X, which one is Y axis. So if you don't have the chart, is it okay if you put the length of the employment in years as a Y axis and the salary?
Absolutely fine. That's absolutely fine. Depending which one depends on the other one.
Okay, thank you so much.
Sure. Perfect. Let us get back to Canvas. Let us download 2.3. Very well. In 2.3, our goal is to analyze the data using measures of general tendency. We can divide measures of center into 3 categories. The first one is the mean, the second one is median, and the third one is the mode. Very well. Let us ask group 4 to read 2.3 for the class. Group 5. Group 6.
In section 2.1, and 2.2, you learn about a graphical representation of quantitative data. In section 2.3 and 2.4, you will learn how to supplement graphical representations with numerical statistics that describe the center and variability of a data set. A measure of a central tendency is a value that represents the typical or central entry of a data set. The 3 most commonly used measures of central tendency of the mean, the media, and the mode. Definition. The mean of dataset is the sum of the data entries divided by the number of the entries. To find the mean of the dataset, use one of these formula, population mean. And I don't know how you read
Thank you so
function.
much. That's absolutely fine. Thank you,
Okay,
dear.
sample mean. The lowercase Greek letter, how do you pronounce it?
That's okay. Let me take it over.
Okay.
Thank you so much. So guys, the measure of center can divide into 3 categories. Measure of center. Measure of center can be either the mean, so center can be the mean, or mode, or median. The most popular one is the mean of the collection, mean of the data. Okay, so how do you calculate the mean? You take all the data, all of them, all numbers, add them all together, add all numbers, divide by the total number of values. So you count all of those values, and it goes on the denominator. That's how you find the mean. That's the definition of the mean. It's a measure of center. How do you calculate that? You add all of them together, all of the values. Mean is equal to the sum of all data. Then you count how many data do you have in your collection. Do I have 20? Do I have 30? Do you have 40, 50, 100? And you write it on the denominator. The total number of values. Okay, when it comes to population, you have to use Greek letter mu, like the cat. Mu is equal to the sum of all x values, all numbers, divided by n. N is the total number of values in the collection. When it comes to a sample or subset of your population, you have to use x bar. X bar, or the mean of the sample, is equal to the sum of all data divided by n. What is n? N is the total number of entries in your sample. Okay? You can use your calculator to find the mean of the data. It's much more easier. So to use your calculator, first, turn on the calculator. Then go to Stat, go to Edit, then you see some columns, L1, L2, L3. Suppose you're using L1. Enter all of the numbers in L1. Enter all numbers in L1. Then go to Stat again. Stat. Instead of going to Edit, you have to go to Calc this time. Then you select one variable. Enter, enter, enter. Then it gives you some results. In this result, you can see X bar, which is the mean of the sample, or just your mean. Very well. One example. In this example, you have a collection of data. Question.
So after you press stats calc, what is the next
One
thing?
variable, one var.
Okay, thank you.
Sure. In this example, we have collection of data. 1, 2, 3, 4, 5, 6, 7. And look at the question. It says the weights in pounds for a sample of adults before starting a weight loss study are listed. So if the question says find the mean, you're working with X bar. It's not mu. Sample, X bar. To find the mean, you add all of the data together, 274, 235, 223, and so on. The outcome is 1,810. Then the mean of the sample is the sum divided by the number of entries or values in your collection, which is 1, 2, 3, 4, 5, 6, and 7. So the mean of the collection is 258.6. 258.6 is in the middle. It shows that the mean of the sample is 258.6 pounds. Any question here? If you have access to your calculator, please practice using your calculator. Go to Stat, go to Edit. In L1, enter all numbers. So you have 7 entries, 274, 235, 223, and so on. Then go to Stat, Calc, one variable, enter, 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 and find X bar. Very well.
After you enter all the numbers, sorry about that.
Go ahead.
After you enter all the numbers, you don't press like enter, you just press stat.
Then you can click on Stat, enter. After entering these data, you go to Stat.
Stat. Okay.
And then Calc.
One variable.
Sorry, I have a question.
Go ahead.
You know, if it's easier to find the mean and median mode, which, you know, without calculator, is it okay if you do that? Or because it's hard for me to sort of.
In this class, our goal is to use a calculator to calculate the values for us. Here you have just 7 numbers. You might see 20 values. You might see 50 values. In homework questions, we have a lot of data.
I see. So you want us to get used to the calculator?
Definitely, definitely.
Thank you.
I post video lectures on Canvas for you to learn how to use your calculator. You have to follow those instructions. For the exam, you can write down those instructions for yourself.
Thank you.
Perfect.
Thanks.
Let's move on to the definition of median. Very well. Okay. What is median? Median is the middle value. So the median of data set is the value that lies in the middle of the data when the data set is ordered. So first, you have to list the data. You have to write them from smallest to largest or largest to smallest. Median, smallest to largest. Then we find the middle value. So how do we find the middle value? Take a look at this example. Now let's get back to example 1. Our goal is to find the median or middle number of the weights listed. Very well. First, we have to list all the data in order from smallest to largest. The smallest one is 223. The largest one is 290. How many data do we have? We have 7. So 1, 2, 3. 1, 2, 3. The middle value is 268. 268 is the median of the data. So I expect you to ask why we need to find median. What's wrong with the mean? Remember that. Note, in highly skewed data, if you have outliers, we prefer to use median. Instead of mean. That's why we define something new. That's why we need a new indicator of the center of the data. Okay, guys, here you had 7 data. What if you had 6 entries, 6 numbers?
Would be the number in between like 3 and 4, the third and the fourth.
Suppose you have 6 entries instead of 7 entries.
Yeah, it'd be it would be the middle number between the third and the fourth entry if you had 6, correct?
So let me explain that by using a different example.
Is it gonna be third one plus fourth one divided by 2?
Exactly. You have to find the midpoint. Take a look at this. Here you have in example 3, instead of having 7 data entries, you have 1, 2, 3, 4, 5, and 6. So how do I find the middle number here? What is the middle number? If I count 3 here, 3 here, there is nothing left here. So what should I do? In this case, the middle number is the average of these 2 numbers. So you take the middle numbers, add them together, divide by 2 to find your median. So note, to find the median, if you have odd numbers of entry, the middle number is the median. If you have even numbers of entry, if you have 10 entries, if you have 12 entries, if you have 20 data, the average of two middle numbers is the median. Any question on example 3? If you have any question, you can use the chat. You can unmute yourself. Very well. What is mode? Mode is the number, is the entry with the highest frequency. We call it mode. Okay, sometimes a data set has no mode. It might have just one unique mode. So no mode, one mode. You might have two numbers with the exact same repeating values, the same frequency. In this case, we have bimodal set. If you have more than two numbers with the same frequency, you call it multimodal. So no mode, one mode, bimodal, or multimodal. Let us get back to previous example. Here you have 1, 2, 3, 4, 5, 6, 7 data. They found the mean, they found the median. Now our goal is to find the mode or the data entry with the highest frequency. 223 is repeated once. 235 is repeated twice. 268 is repeated once, 278 is repeated once, 285 is repeated once, 290 is repeated once. So the mode of your data is 235. Here you have just one mode. Make sense for everyone? Perfect, we have a chat. So the difference of 4 mode, you either have no mode, like this case. Let me write it for you, like note here. No mode, one mode, bimodal, or multimodal. So let us take a look at one quick example to feel more comfortable about this. Okay. So take a look at this collection. You have 1, 2, 3, 4, and 5. No mode here. There is no mode. None of these numbers is repeated more than once. Take a look at this example. 1, 2, 2, 3, 4, 5. As you can see, 2 is repeated twice. So the mode is 2, one mode. Take a look at this example. 1, 2, 2, 3, 3, 4, 5. Very well. As you can see, 2 is repeated twice. You also see 3 is repeated twice as well. So here you have bimodal set. Now take a look at this example. 1, 2, 2, 3, 3, 4, 4, and 5. 2 is repeated twice. 3 is repeated twice. 4 is repeated twice. Here you say that this set is multimodal. Any other question here? Thanks for asking great questions. Perfect, we have a chat. Anything after 3 sets of pairs would be yes, yes. You can say that. Perfect. Okay. So take a look at this example. Now here you have a categorical data. You have first category with frequency 46. You have second category with frequency 34. You have third category with frequency 39. You have last category with frequency 5. So what is the mode of this categorical data? When it comes to categorical data, the category with highest, greatest frequency is your mode. So for categorical data, the category with highest, greatest frequency is the mode. Okay. The first category, Democrat, with frequency 46, it has the highest frequency, so the mode in this collection is Democrat. It doesn't make sense to find the mean of the categorical data. Because you don't have any outcome. Okay, if I say very well, I add these together and divide by the total number of values, what do I get? It's going to be the same thing. How can I add Democrat, Republican, Independent, other together without considering the frequency? It doesn't make sense. So when it comes to categorical data, to find the center, you use the mode. Any question here?
So for categorical data, you don't have any mean?
No, you find the mode, just mode.
Thanks.
Very well. Okay. Let us define outlier. Outlier is a number, a data entry that is far away from the other entries in your collection. Outlier. Outlier in a data set can cause gaps in your graph. Okay, let us take a look at this quick example. You have a collection of ages in a class. You have 20, 20, 20, student 20, student age 20, student age 20, student age 21, student age 21, and 23, 23, 24, 24. Okay, we have a student age 65. This student is considered as outlier in your collection. You can use a dot plot to actually visualize the data. Here you can use a horizontal line, 20, 21, okay, 20. 20 is repeated how many times? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, and 6. So this is for 20. Then you have 21. 21 is repeated how many times? 1, 2, 3, 4, 4 times. So 1, 2, 3, 4. 23 is repeated 1, 2, 3, 4, 4 times. So 23. 1, 2, 3, and 4. 22 is repeated 3 times. 22. 1, 2, 3. Then you have 2 24s. 24. 1, 2, and a 65. So if you continue this line, your outlier is 65, which is here. 1 point for the outlier here. So the majority of the data are on the left-hand side, and your outlier is on the right-hand side. Your outlier. Okay, guys, so let's have a 5 minutes, 10 minutes break. We get back and continue. Azar, you can ask your question during the break.
Sure.
Perfect. Our goal is to find the mean, median, and mode. First of all, here you have a sample. So to find the mean, you have to use X bar, not mu. So you're not using mu. You're using X bar representing the mean of your sample. So the mean of the sample is equal to the sum of all values in the collection divided by n. If you add all of these numbers together, 20 plus 20 plus 20 plus 24 plus 65, the outcome is 475. Divided by how many numbers do you have? 20 numbers you have in your collection. The outcome is 23.8 years. This is the mean of the data. Next, our goal is to find the median or middle number. Very well, you have 20 data, even numbers of data in the collection. So if you list all of them, the two middle numbers are 21 and 22. 21 plus 22 divided by 2 is 21.5 years. This is the median. And finally, the mode. Okay, let's see which number, which age is repeated the most. As you can see, 20 is repeated 1, 2, 3, 4, 5, 6 times in the collection. So the mode is 20. Please take your time, write down the answers.